Yeah. Um, I don't know if it's very visible. I can dim it a little bit more, but it's already like dark outside. Again, this is like third lecture, and similar to previous couple of sessions, the aim is like an hour, at most an hour and a half of discussion of something new, and then the rest of the time is to you to experiment. Okay, so if you are lagging behind the previous two sessions, it's okay. Like each session, it doesn't depend on knowing the previous things to be executed to execute. So today we'll talk about something new called Docker and containers, and so you can do that without doing web servers or renting a machine, a VM on AWS or somewhere else, or cloud functions. So it's not like they are dependent, but they are all related, and that's why they're clustered into the first set. So I wanted to quickly mention where we are. Okay, so it's already the third session, so we're already like a lot of new technologies, a lot of new words that you're probably not seen, especially people coming from Windows or Mac. So there's going to be some friction, but that's a good thing, because that means you're learning something new or hearing something new. And this is a class setting, so it's not that you have to become a total expert in that 1 hour when I discuss those keywords. Okay, those are just to give you a sense of how they're related to other things that you've done. Most of it, I'm going to assume that you've done some machine learning at the minimum regression. So everything else, I'm assuming it's new. So as folks who already have some experience in tech-related companies, that's okay. You can connect it to those concepts. Okay, so where are we? We are still in the first cluster. So first session was mostly focused on web servers. Okay, so we understood what a client is and what a server is. A server is just something that responds to requests, and those two guys or those two entities interact with each other through HTTP protocol. Hypertext Transfer Protocol is just a text-based protocol. Just means rules of communication, rules of engagement. So the client sends a request to respond to something. In our case, the client sends a request asking for a prediction for a particular feature vector or a particular input. Okay, for simple regression, it's just going to be one number. Hey, here's a number, and respond back with some prediction for that number. Okay, so that's you make a request through the GET request, and we saw how to do it a little bit like on the browser. You can just put a question mark, variable name equal to something. And the server is listening continuously till you actually kill that program, waits for such requests to come through the IP address and then the port. Okay, those two are essential to kind of get to the right program, whether it's on the anywhere else also. For example, when we rented the machine on AWS, we had the public IP address. Okay, that's the IP address, and then some port like port 5000 or 8080 or something. Okay. So anyway, in the first session, we talked about the client, the server, and the communication process. Okay. In the last session, we had a few. We were just wrapping up the same thing. We explicitly rented a machine on Amazon. There are actually so many choices that to pursue, but to kind of keep it everything kind of streamlined, we just looked at Amazon as a vendor or which we could rent a virtual machine. Okay. What is a virtual machine? We didn't really, so many of the concepts we are only looking at from the end user perspective, as in we don't have to know the technical details that went into kind of building up some entity like that, like a virtual machine. But the word virtual there just means that the Amazon has figured out a software, and many other companies have figured out software which can virtualize the hardware. Okay, so which means that the keyboard, the mouse, the RAM, the hard disk, they're all present on that virtual machine as if they are physically existing, but they don't. Okay, they are part of some bigger actual, what are called bare metal servers. The actual physical infrastructure is called, the real or the bare metal infrastructure. What you rent is actually a virtualized thing where this whatever software is running there feels as if everything is, physically, present, but those are not really physically present for that virtual machine. They're part of a, that and maybe another 10 other virtual machines all share the same hard disk or all share the same RAM, for example. Okay, that's what virtual means. Virtual means virtualization of the hardware. Okay. So last time we did that, picked a virtual machine, just understood a little bit of security aspects, like ensuring that the port is by default it gives you what is called a at least Amazon, the vendor, provides you, and many other vendors will provide you a key pair, a key and a lock. Essentially, it's through the SSH. It's part of the SSH protocol. It's different from the HTTP protocol. The first S stands for secure, secure shell. I guess I don't know the full acronym, but so it's a different protocol. But the way it works is you have a cryptographic, uh, relation between the key and the lock, so that key is the only key through which the lock will open. Otherwise, server will ignore any other keys that are being used to kind of reach that machine. Okay, so that was a minimal security. But the moment you want to expose your app, let's say a prediction model to the world, which is what we did with the cloud functions. I mean, cloud functions we didn't really put a prediction model, but the same template you can literally. I mean, simple regression it's easy because you'll have a coefficient or even if it's linear regression, you can have multiple coefficients. It's easy to kind of deploy a cloud function or a Lambda function. But we didn't look at the security aspect at all. Security in the sense of it's not, there's no authentication or authorization of accessing those services. Okay? Those are very big industries in themselves in general software engineering of how to give the right access to the right person at the right time. But that's what we did in second session. Second session, rented a virtual machine and then 2 instances of serverless services. Okay, one is cloud function, the other one is Lambda. And in between, I also mentioned something about VS Code. Maybe today I'll also give a quick discussion about that as something new. So today, what we'll do is move to the third, but increasingly becoming important pillar, which is called containers. Okay, containers are just a very nice, I guess, really physically you need to think of them as boxes that ship your program and everything that depends that your program depends on, completely isolated from the operating system where that container will actually run. Okay, and the intermediate file format, it's called an image. I will also talk about what an image is and how do you spin up container from an image today. Okay, that's the scope for today. So it's not really, I don't want it to ramp up like too quickly exponentially. So hopefully we'll kind of revisit some of the things that we saw last time while we try out containers. Okay. Any questions about where we are progressing? So we haven't touched the remaining 4 bullet points, maybe a little bit about VS Code in the last bullet point. We will actually look at Git and some other things interspersed throughout the lectures. Okay, so you will get exposed to some of these other things. Mostly I've been focusing on VS Code, and today also I'll focus a little bit more on VS Code. Okay, easy ideas, but worth pursuing. Any questions so far in terms of our trajectory? We are in the 3rd bullet point in the first bucket. Okay. Okay. There are no questions. Then couple of comments about last time's. We spun up a virtual machine and we also started cloud functions. If you have done that, maybe during the week, then don't forget to turn them off. Okay, so cloud functions by default, there are some very generous provisions by those particular vendors like Google and Amazon. They let you have about 1 million requests without charging you. So that's a lot of requests. But if you're not using it, then it's worth pinning them down. Okay. Big companies, there's actually entire teams which take care of what's on, what's off, who's accessing. There's in fact, data analysts and business analysts also go into cost function optimization. So really on big clouds, given that most companies today are kind of migrating to the cloud for various business reasons. So there are actually analysts as well as other folks, technical folks, who kind of really monitor, what resources being consumed, because these are all resources, just like human resources these are non-human resources, but worth kind of monitoring and optimizing more. Okay, so there are a lot of tools, a lot of companies, and a lot of people involved in these aspects. Okay, but they are not kind of essential to MLOps only. They're essential to in general DevOps or in general software engineering. So I'm not really focusing on that. So spin those cloud functions down, and you can also spin down the virtual machine. But those who just who use the free tier eligible, I think it's okay to leave it on as long as you have your SSH only access for almost a year. Okay, you'll not get charged, so you don't have to be worried about getting charged or anything. So if you have a fresh account and you are free tier eligible, it's okay to keep the machine on for the rest of the semester. Okay, for this course at least. One of the reasons why I'm mentioning that is because I wanted to quickly show, and I think I showed it last time as well. Which is remote server access, okay, for your development. So once you rent a virtual machine, all this complexity that we saw in the first lecture of chaos of, oh, we have Windows, we have Mac and all that, it was just Python installation, which I think is very useful as a business analyst or a data scientist. It's always good to have a Python installation on your local machine, irrespective of what your work is. But after that, if you want to kind of focus your development in one place where you can access it from anywhere else, just run the virtual machine and always connect to that. Okay, and the way to do it, there are many ways to do it. You can just SSH, right? I think we did that on the last time on the command line. We said SSH Ubuntu at some IP address, public IP address, and it's recorded, so we can look at it. But there's a way to command line access that machine, and we installed Python there and ran the Flask app. Okay, that's what we did last time. Instead, another way to do the same is actually just use VS Code. Okay, so I'm not saying VS Code is the only option. There's actually many other IDEs which are really good. A lot of people use it, and there are IDEs for. This IDE is for any language, but can be used for Python. There are other IDEs which are specific to Python, which are also good. And there are also IDEs for just accessing databases. Okay, if you think of, I've done databases course. I don't know if you use an IDE, but they're actually really good IDEs, both commercial as well as freely available, which give you a lot of features. Okay, so it's not so much that, oh, I'm not a programmer, why do I care about an IDE? But in general, the key components in business and analytics related areas, generally access to databases, access to visualization tools. It could be Tableau, it could be something else. There are other options also, or it could be programming if you have to script something and run something on a machine, right? So on VS Code, last time, I think right after the break, I don't know if people were available, I don't know if it was recorded, but I just want to quickly show that there are some very useful extensions that you can install. Copilot being one of them, but let's not worry about that in a second. So one of the key extensions is the Python extension. Okay, at the minimum, you should install the Python extension, recommended to install. It's a proprietary extension by Microsoft in this case, but as it says, it provides IntelliSense. It's just a name to say, okay, it gives you completion. It gives you what methods are available for an object. For example, if you define your own class and if you have a bunch of methods, later on, if you instantiate an object from that class, you can just, when you instantiate an object, if you put an object dot, if you want to call the method, it will tell you what the methods that are available. So it's very easy, convenient. And not just that, basically intelligent completion. Okay, IntelliSense is about completion. And then there's also many other features that you can get. We'll talk about them later. Linting, debugging, I mentioned last time. Maybe today we'll see a little bit of debugging, just an example of debugging. Formatting, unit tests, refactoring. So we'll talk about many of these things throughout the lecture today, not today. Today, what I wanted to say is install Python for sure. If you want to follow along, there are some, if you want to use notebooks, there's also Jupyter Notebook extension. It installs 4 different things, but just install one of them and it'll install a few other extensions. What you're seeing on the this part from install to recommended is the things what I have installed, but it's not like explicitly installed these things called cell tags. It's just a part of a collection of extensions that just gets installed if you install Jupyter. Okay. So that's that. So what I want to show is 2 things. First is the reason I said you can run the machine that we ran last time forever, as in not forever, till the end of the semester or for the next year, is because you can just do use this extension called remote SSH. Okay, so it lets you open any folder on a remote machine as if you're working locally. Okay, that way you don't have to think of, oh, is it in downloads? Is it in this? Or, the Python conflict and that and this. You don't have to worry about it. All the Python is on that side, on the virtual machine. Your code is there. Obviously, you should back it up through Git and stuff, which we'll talk about in a future lecture, how to version control your code. But this is a good extension to use. So I think last time I showed it, but let me. So you just click install here and it'll get installed. I've already installed it. That's why I don't see the installation option here. This blue button here. And once you have it, so let's try. So you will see, how do you get this round? It's Command Shift P, or you can go to the menu and open up this command area. And then you can just go to connect to host. First time you have to add a new host, and there you just have to specify that key, that .pem file that we got from Amazon. You just have to kind of source, say that where the file is. Okay, it's not complicated. If it's in the current directory, you can just say /. This is where the file, that particular file is. Okay, which file am I saying? This one. Last time for me, it was called MLOps _ 2024.pem. But for you, whatever the name is, that file where it is going to be important. Okay. But for me, I have a different machine that I'm going to just quickly connect. I have a GPU machine. It's called, at the bottom, you can see it's called, I'm just calling it tGPU, but it doesn't matter. So I have some name for a remote machine that I have. So I just clicked connect to that machine, right? Same thing, SHPEM file or equivalent of a PM file and the IP address. And through that, I was able to log into this machine. Okay. And now whatever I do, first time it will not show any folder. Just connected to the machine. So let's open some folder. Let's go to class. I think I have a file. I have a folder called class there also. So let me go there. So you can see at the top, it says this is a folder in that remote machine. Okay, so for you, when you have an Amazon machine, you can have a folder there, and then you can do everything over there. Okay, so even the prompt below is actually in that machine. Okay, so you can see that it's a different machine than what I have actually. Okay, what I have here locally. So it could be Windows locally, Windows something else, Mac OS. But remote, everything is going to be the same for you. Okay. Actually, I do have a Flask example, but let me also show you, since I'm in the remote machine, I also want to show you the second thing, which is not so much about this remote machine business, but using AI tools. Okay. How many of you used Copilot before? Nobody has used Copilot? Copilot. So Copilot is by a company called GitHub, which lets you do beyond the IntelliSense that I was talking about. So what do I mean by that, right? So let me go here. So this is a Flask. Let me just close this for a second. Yeah, so this is just a simple Flask app. I think we've seen this for a couple of sessions, so it's kind of hopefully familiar. All that's going on with these types of frameworks is they're mapping a route, IP address / something, in this case, directly the root location to a function. Okay, that's all that's going on. They could have more things like this, right? So okay, now actually I'm having a conflict with this. Okay, so it's a second function. So two different routes / leading to first function hello, second root IP address / I guess in this case hello again, to a different function called hello new. So all I'm saying is this is what any such web framework would do. Now instead of showing IntelliSense, I'll directly show use of Copilot, right? So this is what, if you open a new file, it is all on remote machine, but I installed Copilot. Okay, so it's again click install once you find Copilot, and all it will ask you, and for students actually I believe it's free. Although you should check it, but I think it's free, so you should be able to access it. Otherwise, it's $10 a month or something. Okay, but Copilot is not the only solution. There are many solutions, but it's one of the earliest ones. So it's already saying, right? So press something to ask GitHub Copilot chat to do something for you. Okay, Control I. So let's say write a Flask server that responds with the name. Okay, I don't know. And that was passed in the. Okay, let's try. I haven't tried this before, but let's try what it does. So this is what you get, right? So if you want quick helper functions, or at least some initial things, so that you can then debug it and adapt it. So actually, I didn't try this before, by the way. This is live, but it's not a complicated program. Flask hello world type functions. There's a lot of people have written it, so it understands the patterns that need to be generated. But it could be anything, probably more esoteric, like maybe a specific problem that you have in your day-to-day work. You could kind of try to rely on them a little bit. Okay? They are not a silver bullet for everything. Otherwise, why would they need us? But they help you accelerate your speed. Okay, so here it pretty much does the same function, right? So it's actually saying there's a get request that this method is going to accept, and then in the request.args dictionary, you can get the name variable, and whatever the variable is, that's going to be returned. So this is one of the big use cases. I just showed you one, but you should get it set up and try it out on any of your programming assignments. I don't know what the policies are for other courses, but here you can you can. So okay, so this completion here is also by GitHub Copilot. So it's actually saying, okay, typically you would give a port parameter and some port number. And when you get the suggestions, you can hit a tab and you can make it valid. Okay, so let's save this. And now so on when you're on VS Code, it also opens up a terminal on that remote machine. So on your Amazon VM, you can, what you see at the bottom is the command line from that machine. Okay, so here it turns out in my machine I already have Anaconda installed, and the environment is called virtual environment is called base. Okay, so remember there's a Conda way to create virtual environments, and there's a Python way to create virtual environments. Conda way is a little bit different. Conda is like the command, and it's by that company called Anaconda Python. So it's a little bit different because it does a few more things that Python virtual environments by themselves don't do. Okay, it can install other software also. Okay, that's the difference. So one way to Conda create, I think we saw this last time. If not, we can just show it later. So if I run Python, I think it's class example. So it's running on that machine, but it already does port forwarding for you. Okay, so I don't know if I had to run. So I guess no name, I guess no something was passed. So we can just give question, right? So although it's a remote machine, it will show up as if it's on a local machine. Okay, it's something behind the scenes that I can explain, but it's kind of nothing new. Still, the SSH protocol, there is a way to kind of expose things running on the remote machine as if they're running on a local machine. Okay, by just basically port forwarding or something like that. That's the idea. So this way you can develop things on your remote machine and still be, you can connect from anywhere and doesn't shut off. You can run the service all the time. Okay. Any questions about this? So this is just a quick VS Code and remote SSH and then Copilot. Those are the three things I just showed today. In the future sessions, we'll talk about linting and styling and so on. Okay. That's yeah.
In terms of setting up environments on virtual machines,
yeah,
you said it's pretty in terms of like using the kernel syntax.
No, I mean here I'm just using. So for example, if I open one more terminal, so that way you get rid of corner. Now, if I say which Python, okay, which Python 3, there's no Python app. So it's the system Python. So user/bin/python 3 is the system Python. I can create a virtual environment based on Python 3 also, Python 3 minus m when. And actually, it turns out if there's a venv folder inside, let's say class, VS Code will figure out that you are actually using a virtual environment. It'll load that. It'll use that Python to run your scripts also. But I would say there is no, if you're only restricting yourself to Python only packages and so on. So I would say just go with virtual environment package inside Python. But Conda is useful if you, for example, if you have GPU requirements, if you have to use a GPU and NVIDIA related software, that's a little bit more easier to work with Conda. Another key difference that I already mentioned in the class, and you can look at the lecture sessions, is that with Conda, you can change the Python version. Okay, so here it's an old version, Python 3.8, actually, pretty old. But if I wanted Python 3.12, the Python virtual environment approach will not give you 3.312 or 310 or something. You have to use something else, and Conda is a way you can specify which Python machine. That's one big advantage, but it can do many other things. Yeah. Okay, so that was about yeah, just to summarize, it was about VS Code, Copilot, and remote machines. Okay, remote machines make your life very simple because you're not struggling with, oh, Windows, how do I do XYZ? That's just very it's doable certainly with Windows subsystem or Linux, but it's just less painful. Okay. Lastly, I wanted to briefly mention a couple of things relating to servers. Okay, so we tried out Flask, right? I'm going to talk about very briefly talk about three different server frameworks. Okay, frameworks just means think of them as packages. Let's like Flask, pip install Flask. You can do pip install this thing called Streamlit. It's a way to build apps, especially data related apps. Okay, data science, prediction, visualization related apps. Okay, so I don't know if they have a good. Actually, they have a gallery. Project. Okay, they have a gallery. So I guess they have on the left side, you can see natural language processing. You have text classifiers, A/B text. So there are a lot of apps, and you can actually see the code also. And so you can actually get a sense of how these apps. Okay, these could be internal apps in your own company. If somebody in the finance department needs some quick quick and dirty outputs, and you as a business analyst can spin up such an app and internally expose it to those users. It's a very quick improvement in workflows, right? So I'm not going to focus on any app here because there are a lot of apps here, but you can see how to plot things, right? So for example, I don't want to particularly open anything. Yeah, how to quickly create a graph with all these tooltips, and also have a menu where you can click around menus. So these things you can do it with other technologies, which is a little bit more mainstream software engineering, right? HTML, CSS, JavaScript, and everything else related to it, like TypeScript and front-end frameworks and whatnot. But if you wanted to have something quick and dirty to show, especially internal consumption in the companies, you can just use this. Okay. I mean, obviously, look at the license. So this is the reason why I mentioned this is a replacement for Flask. Instead of Flask, you could have just used Streamlit also. Okay, it's a little bit different way of spinning it up, getting started, but instead of Flask, you can just stick with this if you want. Okay. Second thing is much more, actually, much more involved, but very, very popular approach in Python called, which is a web framework, general purpose web framework, not just for machine learning models or anything like that, or data specific. It's called Django. And big difference between this and Flask is considered a lightweight web framework. You just saw, right? Import Flask and then put a router and then a function. Here, you can have classes and a lot of other things. By a lot of other things, I think one of the key things is a database. Okay, many times you may have to kind of log, information in a database, retrieve information from a database, edit information from a database. In Flask, you can do that, but you have to explicitly kind of import a package and spin up a Postgres or some other database and actually make connections. Django makes it very easy. Okay, so database access is is one of the big benefits. And then kind of working with the database. Okay, they have a nice feature called admin, Django admin. So you can just go to whatever your URL/admin, they would have populated. Okay, here's the database. These are the entries in the database. If you want to edit it, you can directly edit from the UI. Okay, so you don't have to write command line stuff. So this would be another replacement for Flask, but more involved because it sets up a database. Okay, so it won't set up Postgres by default, but you can set it up with any database that you want, like Mongo or Postgres or whatever. Okay, and it also helps you easily get authentication. Like if you think of username, passwords, and forgot password and all that stuff that you see in regular apps, if you want those features, then this would be a good tool to start with. Okay, and the last one again, replacement for Flask is this thing called Fast API. I mean, there are many solutions here. I'm just showing you the popular ones. So Fast API is, according to what they say, is a I guess more modern than Flask web framework for building APIs. Okay, it's behind the scenes. They mention all these features that that are, I guess, a little bit more enhanced or differentiators compared to Flask. Okay? Flask is really quick and dirty. It was very easy, but these would be more, if you want more, some of these features, right? So if you want some of these features, then you can go for them. I'm not going to list them. I just wanted to show that there are 3 other alternatives just for one package that we used, just for one language, Python. Okay, so there are many choices, but if you understand the basic idea, okay, here's a client, here's a server. How does the server run? What's an IP? What's a port? And a few things like that. You will be more comfortable with any tool, okay? Even though they may have many different words, but the basics are going to be similar. Any questions about these 3? No? Okay. So that was about that. Yeah. Lastly, I wanted to lastly, I wanted to kind of show you what is the extreme end of this collection of things that we're seeing: web servers or serverless or containers. That was all about exposing machine learning models, right? So today, the Copilot feature that we saw is exactly that, right? So there's a web server sitting on GitHub's data center, and it's actually in real time seeing what you've written. That goes back as a post request in this case. With authentication, it knows that I am the GitHub user and I have whatever credentials or permission to use Copilot. And it's real time. There's something behind the scenes. There's a GPU running with some model, and that model is predicting, okay, let's produce these words, and that's returning back. So with Copilot, you already saw an example of this client-server interaction. But if not Copilot, at minimum ChatGPT, right? So this, I hope everybody has created an account, and because this, at least the lower version is free, right? So you can, so even this, right? So this interface is your client running in the browser, but it could run anywhere else. Okay, you could have a authentication key from OpenAI, and you could run from your own Jupyter instance or your own Python program also. Same thing. But this is the client running locally on the front end in the browser, in our memory, in our system's memory and whatnot. And you're making a post request typically on OpenAI servers, and that is so well provisioned on that side. This is the extreme engineering today, right? I mean, we are just scratching the surface of what is one aspect of MLOps, which is serving machine learning models. This is an example of something that can scale to tens of millions of users or hundreds of millions of requests per second, or not per second perhaps, but per day or whatnot. So how many GPUs behind the scenes, how much engineering has gone in to just do this, mimic this client server architecture that we saw in our slide. Okay, it's exactly the same, but a lot of things to kind of ensure that hundreds of people, thousands of people accessing at the same time, it still works. Okay? There's some GPUs running, some models running, actually multiple copies of models running. It's not one model. It's the same model, but probably multiple copies. So all that is doable by this. And just to give another example, I had here. Yeah. So this is a company that recently raised a lot of money, just yesterday, actually, probably day before yesterday. It's a company called 11 Labs, and it creates text to voice, okay, text to speech. Okay, and here their demo itself. Let me just refresh this. They have a demo here which does exactly the client server thing that we're talking about, unauthenticated. So they are doing something behind the scenes to ensure that it's not, bringing their compute down or basically bringing their servers down. But this is a demo, no login required, right? So if you pick some language, I don't know if you can hear. If you surrender to the wind, you can ride it. So this is their, I guess business value is that they can create realistic voices, not like, speech that is in, very robot-like. They're making more natural, and you can change things here. But this is just a demo. I'm just saying that this is again an example of a client server behind the scenes that's running this on their machines, their data center or whatever, or maybe it's on AWS, for example. But they're able to do a quick turnaround from you typing something to a model responding that. And this is just, it's not, it's a great feat in 2024 that you have these examples of what can be achieved at scale. And obviously, many companies will not have such requirements. I mean, you have an internal facing app doing maybe visualization, maybe a smaller model, maybe a more focused business application focused model, but it's the same ideas, right? Yeah. So, okay. Lastly, I do want to one more thing before we get to Docker or containers, which is last time I was talking about security, right? We spin up a machine. We had the security, which is the securely accessing your server. Okay, there's a whole other bunch of security which we will not talk about in this course, but is actually very important and very relevant for data science business analysts and data scientists folks. Okay, which is just the security of the model. Okay, in the sense that the model is not off. Maybe at training time somebody kind of messed up your training, or the data that went into the model training that is corrupted for some reasons, or your output could be sabotaged as well. So there is a popular so OWASP is a organization. It's more famous for web security. They have a list of top 10 factors that you should consider for web security in general, like web app security. But here's a list for LLM applications. LLMs are, I guess, very popular these days. So they even have put out a list for large language models, like what is the security aspect of it. Okay, it's worth looking at. I mean, I just picked the slides that they have where they just mention what the issues are. Okay, let's actually just look at the first security issue, prompt injection. Okay, this is something where the inputs are being corrupted, or inputs are undesirable. That's leading to some data leakage or undesirable output or whatnot. With LLMs, it makes sense. So output handling, which I guess, yeah, basically, on the output side, you're not securely sending back the information to the user who asked the information. Maybe you send it to somebody else instead of the user, and so on, right? The third one is training data poisoning, which is actually not just for LLMs. It makes sense for even any other data. So if you're getting data from some upstream vendor, okay, maybe you didn't collect the data, maybe you commissioned some company, right? So to get the data, and they get the data from real people. What if the people are kind of giving wrong answers, or at least not being kind of truthful in their answers? But that's actually mild form. If there are competitors who are explicitly attacking your data sets which you're gathering, then you're going to have issues. Okay, so these are things that you have to think of. Some of these are related to web services as well, right? So model denial of services, like for example, MLOps has a model that anybody can say, okay, give me the audio for this text, right? What if like somebody creates a bunch of clients, thousands of clients, millions of clients, which all hit the same website and ask for a audio stream? That means that it's basically it's going to create what is called a denial of service situation, where any legitimate user cannot actually get the service. Okay? So they will be so overwhelmed, in this case, 11 labs, that you will not be able to serve your actual real users. Okay, so I'll not go through all these lists, but it's a very good list to look at. Okay, this is relevant because of the intersection of data science and MLOps. Okay. Yeah. Any questions? I've been talking about everything else because I thought these were things that I wanted to point out, just to reinforce the client server idea. I mean, because why are we looking at client server idea is because that's the underlying concept behind many things that we see in the world today. Now, the same client server idea, we're going to do it through Docker. Okay, Docker or container technology. So let's, if there are no questions, we'll switch over to the key idea for today. Okay. Any questions or comments? Okay. Come back here. Just to quickly show, this is what we saw 2 lectures ago. where we explicitly instantiated it locally. I mean, we didn't have a server in the first lecture, so we just ran the Flask app locally. But it's the same thing whether you run it on a remote machine. And after that, we did this. Serverless technology is not really it's not distinct from what we have already seen and what we'll see today. In fact, containers and serverless, they're very related to each other, except that serverless is a proprietary technology mostly, in the sense that the Lambda functions and cloud functions that we saw last time, they're just proprietary technologies for us from a user perspective. Behind the scenes, they could have been implemented exactly using containers or some custom, programming that they've done, custom software that they've written. Okay, so we use the UI to create a serverless function, or at least create a simple serverless function on both vendors, AWS and GCP, and then we just saw how to at least do hello world there, and then you can do same thing with regression, simple regression, right? The moment you go beyond simple regression, let's say if you want to include scikit-learn, or if you want to use PyTorch or something more complex, there's going to be increasing complexity, increasing dependencies that you have to take into account. Okay. For example, even if you don't use PyTorch and scikit-learn, if you just need NumPy, okay, maybe you need to do inverse A inverse B. For example, if you're solving linear regression, you could solve it using matrix inversion, right? So if you have to compute a matrix inverse, you might need NumPy, and to add NumPy dependency into cloud functions is not impossible, but it requires a little bit more effort. Okay, but it's worth trying out. Okay, because especially serverless, the whole promise is you don't have to worry about anything about reliability, about maintaining operating system security and all that. You just log into the web UI, paste your function, and that's it, right? There's no SSH, nothing else needed. So we did not see the command line tools last time. It's something that we can discuss if needed later. It could be a good project, understanding these command line tools like gcloud, AWS, and so on. These are command line tools that are available by these vendors for invoking and creating virtual machines through command line if you want. Anyway, so let's come to containers. What is the core idea? It's the same. We want to create a server and we want to interact with the server through a client. Okay, so what you do is where the program eventually resides, you don't know whether it's on an Ubuntu machine on AWS or it could be a Windows machine on Azure. Okay, you wouldn't know. Let's say you don't know, undecided, but you want to ensure that wherever the program runs, from the program's perspective, it's exactly looks the same. Okay, so from the program's perspective, in the sense that if the program has a dependency, it's the exact same dependency whether I'm running it on a Windows machine from Azure or a Ubuntu machine from AWS. Okay, it should look the same. So this level of portability and isolation between what the program needs and what is available in the OS, the operating system, for example, that's running on that appropriate virtual machine on that vendor, they're decoupled. Okay, so that decoupling is already achieved through virtual environments a little bit, because by virtual environments, we are ensuring that we have the same, we are not coupled to the operating system related things. It's the same idea, but really kind of stretched to the extreme, where what you do is virtualize the software. Okay, so if you want to really think of what is virtual machine versus a container, virtual machine, you can think of virtualizing of the hardware. Okay, so the RAM, the CPU, the hard disk, that's virtualized from the perspective of programs running there. It looks like there's actually a 100 gigabyte hard disk. There is actually no real 100 gigabyte hard disk. It may be part of a 1 terabyte hard disk that's sitting in the actual cloud vendor's data center. Okay, so that's the virtualization of hardware. Virtualization of software is where, from the program's perspective, it'll look as if it's an operating system within which it's running, which is different from the operating system that's actually running in that virtual machine. Like it could be a Windows machine, it could be a Ubuntu machine, it could be a Mac even, but your script is not, it doesn't know that. Yeah.
So would WSL be an example of container?
Yes, WSL is a container. Yeah. Windows Subsystem Linux is a container. Yeah, technology. So this picture is just showing that you could do local development of your app, package it into what is the precursor to a container. It's called an image, but just think of it as a container image. It's a long word, so we're just calling it an image. You write your Python script, which we have our Flask example. We're going to put it inside a container, and then more appropriately container image, and that image can be, it's basically a zip file or just a file. Okay, it's like a text file, or for example, you just kind of push it or transfer it to any machine, whether the Windows machine or the Mac OS machine or a Linux machine, and then you can run your program. Running the program means the container is running. Okay, not it's running from that image file, and when it's running, the program inside doesn't know whether it's Windows or whatnot. Okay, it just runs. So that's that indifference, or that no change in what the program sees, is actually a big win for development. Okay, so you can't say, hey, it was running on my machine, but it's not running over there. Okay, that reason is not going to work anymore. Okay. To enable that, you do have to have a container runtime, as in some program that lets the container run. It's very similar to, I don't know how many of you have programmed in Java. Okay, on Java, there's this notion of bytecode, and there's Java virtual machine. Okay, don't worry about the acronym there, but JVM is a runtime which runs the bytecode so that the program runs. Okay, so your Java code compiles to bytecode, and then the bytecode is what's run on the JVM. It's not exactly the same here, but think of you're putting your program in a box, and you're shipping the box to any location, Windows machine or whatever. And then there is some program there that lets that executes that box, so that inside the box your program running doesn't know that it's running inside a box. Okay, it's virtualized. Software is virtualized, so it's, it doesn't matter whether the box is running in a Windows environment or a Linux environment or a 100-year-old technology. It doesn't matter. Okay, that's the idea. So, any questions about conceptually what's going on? I want to show you a couple of figures. Let me just do that to kind of drive home this idea. Yeah. So, yeah. So I know this is not the most optimal way, but I just want to focus on the figures only. Okay, don't worry about the text. Text is it's already there in a repository. You can read it if you want. But the text kind of shows you what. I want to focus on the figures. So there's going to be 3-4 figures. I just want to mention that just to show just at least the block level what do you need to be aware of in terms of how computers work and how do containers work, right? How does a computer work? Okay, this is a very simple diagram of how a computer works. There is resources, a CPU, a memory, a device like a hard disk, keyboard. These are all devices. And then there is a program, a very important program in your operating system called a kernel. Okay, Windows has Windows kernel, Linux has its own kernel, Mac OS has its own kernel, Android has its kernel. What is it called? Chrome OS has its own kernel. So all of them, there's a key program that every application running on your computer, for example, requests resources to that program, and that program is the one which divvies up and gives those resources to this bunch of apps. Okay, it could be the Zoom app, it could be the browser, it could be anything like a Word app. Okay, any app here, they all need to ask the kernel for resources, and the kernel gives them resources. Okay, this is what's happening in your operating system, currently on your machines, okay, or any machine. Typically, this is the predominant architecture. Okay, and let me skip that for a second. Now, let me just show this picture now, which is just showing. I feel like it's too light, but can you guys see the image? Okay. So on the right side is what we got last time. Okay, last time when we so with the right side, I mean where my cursor is. Can you guys see my cursor? This image over here is where you can see how a VM runs. Okay, a VM is a virtual machine that we rented from Amazon last lecture. So the way it runs is Amazon on its physical machine, which has an explicit, physical real-world CPU and a real-world hard disk and real-world RAM memory, it runs a special thing like an operating system called a hypervisor. Okay, you can think of it as an operating system also, but it's called a hypervisor. And then when we ask requests for a virtual machine, Amazon says, okay, hypervisor, give them a virtual machine, and then you get instantiated with a virtual machine with some specs that you chose in the UI. Like you said, oh, I want 2 CPUs, I want 8 gig of RAM and so on. So that gets allocated. So that's this white box here that you see, one of the virtual machines. The other two on the left and right are their own virtual machines. Okay. Now this virtual machine has an operating system. Okay, that's called the guest operating system. Just to differentiate it with the other operating system, which could be the hypervisor or the host operating system. Okay, so you don't get to see the host operating system for Amazon. You know, because from your perspective, you're just asking for a computer or you're asking for a virtual machine. They just give you a virtual machine. You choose a guest operating system. We chose Ubuntu, I think, last time. Okay, and then the operating system comes with all sorts of supporting files and files. You know, you would have seen hundreds of directories in Windows, right? In the Windows folder or whatnot. All those files support the execution of top level programs like Zoom or Word or whatnot, right? So that's what a VM is. This is an isolated, virtualized laptop, basically running inside a bigger physical machine. That's what it is. Okay, so you could have tens of laptops on the same machine. So each laptop user, from their perspective, it looks like a real machine, but it's not. Okay, the hypervisor is the one which kind of virtualizes this hardware so that from the guest operating system's perspective, it's as if it's getting real hardware, but it's not real hardware. Okay. Now, for containers on the left side, you can see that the infrastructure, in this case, we don't need a hypervisor. Okay, it's just going to be some host operating system like Ubuntu itself, for example, or it could be anything, any operating system. And then you have a special program which is used to both run containers, but also help you curate and manage containers and even build container images and so on. Okay, that program here in this example is called Docker, but there are actually many programs like that. Okay, and but in terms of execution, let's say you execute a container. So what does container see? So this is an example. This white box here is an example of a isolated area. Okay, on the left and the right are also separate containers. Okay, left is app A, center one is app B, and right one is app C. So what is container? So what is inside this container isolated box, which is different from a VM? Okay, from the VM, you can see that there are two things: app and the bins and libs just mean binaries and libraries. Okay, some supporting files that are needed for your app to run. Okay, those are there, but there is no guest operating system. Okay, so the container doesn't have an explicit guest operating system. So this intermediate program, Docker, is proxying resource requests directly to the host operating system's kernel. At the end of the day, the kernel, remember, I think in the first figure I said the kernel is the one which actually gives you resources like hard disk or RAM and whatnot. So the intermediate program, which in this case is Docker, is whenever the container needs some resources like a hard disk or RAM or whatnot, it proxies that so that the host operating system kernel provides those resources. Okay. Whereas in a VM, we already get a reserved area of RAM and hard disk and whatnot compute. And so guest operating system has a kernel running, which uses those virtualized hardware, it divvies them up among the apps. Okay? So there is an extra kernel here. There's a kernel here, two levels of kernels in the right figure, and only one kernel on the left figure. Okay, that's at least at the block level, that's the difference between containers and VM. So containers, typically you would think of them as a little bit more lightweight, maybe a little bit less kind of secure, because there's no extra operating system going on. Also less complex. Okay, if you want to think of that. Okay, so those are two figures I wanted to mention. Next, let's look at Docker. And this is the last figure, and then we'll try out a demo soon. Okay, so what are we trying to do, right? So we obviously have let's say we have our Flask program that we want to containerize so that we can run it anywhere. Okay, to do that, we will install some software soon. But the way we're gonna this workflow, this way of using our program and packaging it into a container image, and then running containers out of it, that workflow requires a software. In this case, there is a program called Docker Daemon. Daemon just means a server. Okay, the Daemon server kind of synonymous. So there's a program called Docker Server or Docker Daemon. Okay, and there's also another program called a Docker client. Okay, those are two programs that you install. Okay, the client can be anywhere. It could be on a local machine. If you're creating, it could be on a local machine. It could be on the same machine. Okay? In our case, we'll see that we'll do it on the same machine. Okay, so the client interacts with the server, and asks the server to create a container image or delete a container image or download a container image and so on. Okay, so client is just asking. It's just a way to, just like we have on the browser, or we had clients to make GET requests and so on. It's a very similar. It's a different protocol, but it's a very similar idea. The client is making requests of, let's create a container, let's delete a container, let's do something with a container, run a container, right? So you can see build, pull, run, their specific verbs. And then the server is the one which is behind the scenes managing all these commands, as in like trying to get these commands to run, right? So for example, it may be already running a bunch of containers. So it's tracking them in case you need to delete or stop them. It may be helping you create those container images, right? Maybe our Flask app, we want to containerize it and create an image to be shipped off somewhere else. Then it lets you help create that image. Sometimes these images have to be created from what are called base images, like an Ubuntu base image or whatnot. So there is some detail that it maintains. So it maintains these pre-built, I guess, part of the container solution, with which you can create your own full container image. Okay. And then there is actually a remote location where you can publish these container images, just like GitHub. You can publish your code. Here you can publish your container image so that anybody else can download, and their operating system, whether it's Mac or Windows or something else, your app will still run, okay? Because your app is coming with it. So all its dependencies in a nice box. So you don't have to, you don't have to worry about whether your app is going to run in a third-party location, okay? So, so that's what we're going to do. And how we're going to do it, historically, I do have notes here, but we're going to not look at the notes. We look at Docker's documentation, okay, and just go through an example. That's what we're going to do. Actually, Docker is a company which provides one version of this whole workflow. Okay, the other companies, but we look at Docker, and Docker today has actually made it super easy through a UI called Docker Desktop. So you can install it. Let me open it. Yeah, so you can install something called Docker Desktop. I'm not going to install it, but you can install it. I just want to show you a simpler way, but you can install it. You can download for any. Oh, should not have done that, but so you can get it for Apple and Intel if you have older Macs, or you can download from Windows or Linux. Okay, it's just a UI to kind of see which containers are running. You can just click and stop and start and stuff like that. Okay, which container images you have and so on. So it's very useful for sure. Okay, so okay, actually I want to talk about AML, but let's not get there yet. Let's see. Yeah, so sorry, they keep changing the UI. So they have many getting started links that you can try out, but we'll just do we'll not read all this text. We'll just kind of, since I explained what the programs are. So first step is just install Docker Desktop. That will install both the Docker's daemon and the client will be just the UI itself. So you don't have to do anything more. Here's a more technically accurate definition of what is a container, what is an image, and so on. But let's just directly get to this step, okay, which is containerize an app. So it's saying we have to install Docker Desktop. I have not installed Docker Desktop, but I've installed the Docker program. You can also install just the program, not the desktop. Okay. I'm saying you need a Git client. Git client is just to kind of Git clone an example repository. Okay. And it's saying you need an IDE or some place to edit text files. Okay. So step one, let's just follow. So I'm just going to follow this mostly because this is up-to-date data, and you can just not rely on notes, which will probably use older information. So what are we doing, right? In the next, few steps, we are just gonna spin up a simple app, and it's actually some sort of to-do app. It's not even in Python, it's in JavaScript, but that's irrelevant. Okay, it could be, we'll actually spin up our own prediction model also very quickly. So let's just git clone this. Okay, so this is on that remote machine. Actually, I don't know if Docker is installed here, but let me. Yeah. Okay, now I have both Conda and the virtual environment. Let me just deactivate one of them. Okay, so this is our, this is what we install on day one. So let's just keep with that. So what do we have? Currently, we have some things going on, but let's say git clone. Oh, let's double click git clones. Okay, so git clone. So what happened? There's a extra folder called getting started, right? So this getting started app. So it has a bunch of files here. For us, it's not going to be relevant. Yeah, it has a bunch of files. What we're going to do is just create a file. Okay, this is the most important thing, which is, actually, I'm wondering if we should just use our own example. Okay, let's just use our own example for simplicity. Let me just close this. So on MLOps code examples, there is a folder for Docker examples. Inside Docker example, you can just click on the first one, which is called Docker_example. Okay, that's the subfolder there. And that folder has 3 files here, requirements.txt. Requirements.txt is a very standard way to also standardize, the same dependencies are used across machines. Or if you're running a Flask app, and let's say your team member also needs to run it so that they can debug some aspect of it. The Flask, for example, is a dependency. Then you want to have the same versions running on both sides, because if it's a different version, there may be different capabilities or different ways to kind of do things, right? So actually, in fact, this requirements, I think this is like a pretty long route, but so if I go to Python shell just for a second, and if I import Flask, right? I can check the version this way. I mean, it may say it's deprecated and there's other ways to check it, but this version is 3.0.0, right? This Flask version, this particular package, and you can check most packages will have this attribute called __ version, just to know which version you're running. So I can explicitly say Flask is equal to 3.0.0 here. Okay, that way, when somebody else gets these files, this requirement file and the Flask whatever our app, they can. Sorry for the. What they can do is they can say pip install -r requirements. Okay, -r just for where is the requirements file, that's in the local directory. And if I do pip install, you'll see that it said something, but basically it's saying it's the same requirements, everything is satisfied. Okay, if I had changed this Flask to, let's say, 2 point something, then it would say, oh, you have Flask 3, but what the project requires, slash 2 point something, it'll uninstall the old one and install a new one. So install the what you actually need. Okay, so anyway, this is a requirements file, and the second file that we already saw, which I've simplified many times. So let me perhaps simplify it again. But yeah, so this is just 2x plus 2. I mean, let me not simplify it. It's pretty simple right now. So this is the app. It's the same app as in the first lecture, and maybe in the second lecture we didn't probably run any of it, but it's the same app. Okay, so there's nothing going on. It's just a simple regression app. Okay, so those are the two files. The only new file is the requirements one, and the third file, which is the most important one for us, is the Docker file. Okay, so let me just focus on this. So this is a file that specifies how to put our things in a box, in this container image, from which we can spin up containers, and they'll, when those containers are spun up, the program inside the container, it'll look as if it'll look at, oh, I have Python, I have everything, Flask, everything installed. It doesn't matter what the operating system has. It could be Windows system or Mac OS, it doesn't matter. Okay. So we will parse this, again, perhaps later, but basically it's a very simple text file. It's a it has a domain specific keywords. Okay, so this is called a domain specific language, if you want to use that phrase. But basically it's saying start from some starting point. We are just saying start from some operating system like Ubuntu, or Debian is another operating system, Linux operating system. Okay, so you could potentially say Windows 11. I mean, that's not possible today, but it's exactly the same. That's what the first line is saying. Okay, next line is saying install Python. Okay, we could have said we could have said there's something else, but here we're just saying update the packages, update the software in this starting point, and install Flask. Okay, now where is this update happening, right? So remember, this is a creation of the box. Okay, what is that box? It's a bunch of files at the end of the day. Okay, because when it's run, it's a virtualized it's virtualizing the operating system. From the files point of view, it looks as if there's an operating system there. Okay, so that's what these files are. You start with a bunch of files which look like the operating system files, and then you're saying, okay, let's install anything new that is needed. In particular, we want to install Flask. There'll be new files added up. Okay, and then we'll copy our file. Okay, that's happening through this line 6. Copy dot to dot just means copy the current directory to this image or bunch of files that we're creating. Okay, work directory is just change the location of where my file should run. I mean, it's not that critical. Okay, it's just where my file should run on this once this container is spun up from the container image. Okay, so all these steps, what does the this is a file. It's just specifying how the image is defined. Okay, it's just a definition of a container image. Okay, once we execute this, execute some steps based on this file, what we're creating is a container image from which we can spin up a container. Okay, so what is this image? The image is just a bunch of files. Okay, what are these files? Starting with some OS related files, which are unrelated to whichever operating system your container is going to run. Okay, your container might run a Windows machine. These files are related to some Linux operating system. Okay, so each of the steps basically is adding files on top of files, so that in what is called a layered fashion, and that way you get an image at the end of it. Okay, so this is a run command, execute something, change the work directory, copy the current files. Instead, I could have just said copy the Flask explicitly, like here. I could have said pi to the whichever location it is, and then entry point just means when I run the when I run a container from this container image, which is just a collection of files, it looks like a single file, but it's a collection of files. Then it just runs our app. Okay, so that's what this file is. So what I'm going to do is again go back to the instructions, except we'll just ignore their app. If their app is a to-do list, you can run them. You can run it also. It's a good feel for like a different non-Python solution. but they have a very similar file here. Okay, they are saying, okay, start from something called Node. Node is an execution engine for running JavaScript files, very similar to Python is an execution engine. Interpreter is an execution engine for running Python language scripts, right? So they're basically doing the same thing: work directory, copy, run some dependencies, and then they're doing something extra like expose a specific code and stuff like that. Okay, these variations in the commands you can look it up in documentation. But at the end of the day, this is just a what is called a Docker file. Okay, this is an important file. I mean, this is kind of the canonical file that you create called a Docker file. And then what you can do is create this container image. Okay, how do you do that? You can just call the command docker build with a tag. -t means a tag is just -t means just a name. Give a name to this whatever you're building. For us, we are building a prediction flask, regression prediction model. So we can just call it prediction, for example. So let's run this same command here. Okay, so docker build -t or whatever tag we want. Let's call it prediction. And then dot means in the current directory, find the Docker file. Okay, this Docker file you can see is in the current directory, which is in Docker example folder. That's what we navigated to, and now we are in the Docker example folder. Okay, and so dot just means find the Docker file in the current directory. So let's execute this. Okay, now okay, there's a lot of I have a firewall. Let me disable that. Okay, now you're seeing a lot of steps happening. Okay, so what are these steps, right? So this is explicitly this is step 2 of the 4 steps in the Docker file. Okay, in the Docker file, step 2 is saying run apt-get update and install Python pip so that I can install pip install Flask. Okay, that's what the second step is saying in the second line. Second, third, fourth line is just one command. That's the step that's happening right now. Okay, and then you'll see step 3, which is just changing the work directory and then copying happen. Yeah. Step 3 is that work directory change. That's what you'll see. Like the keyword, the next purple keyword is the step 3, change to work directory, and the last keyword is copy. That's the 4 directory. An entry point is just a instruction to when we spin a container from this image, container image, then which file to run. Okay, so that's what's happened. And it's okay to, by the way, make mistakes here because it will cache things. In a sense, if you make some mistake in the later step, previous steps that were computed to create this collection of files, it's not going to recompute it. So it's fine. Okay. So, okay, we created a Docker image. How do we know that? If you have Docker desktop, it'll just show up as a row in that UI. And so you know that, yeah, we have an image from which I can spin up a container. If you want to do by command line, you can just type Docker images. Okay, so we just created a image. In fact, it says, I guess the technical name is repository. And a tag is, if you don't give a version number or something, it just says latest. Okay, so latest is like a always running. You can move that latest tag to other, if I change my model, maybe it's improve model, you can call that latest. Okay. There's some internal ID, when was it created, and how big is it? You can see that it's huge. Okay, it's 500 MB. Okay, it's smaller than a virtual machine. Virtual machine will go into gigabytes because it's a fully, it's a full operating system. This container is going to be 500 MB. If it was just your Python file, it's like less than 1 KB, perhaps, for the file that we have. So there's a huge disparity. But this 400 MB, 500 MB thing captures everything that's needed. In fact, it has a lot of excess things which are kind of not relevant to us, but it at least has our Flask script and the Flask package and all the Python standard library things which are also used. I don't think we use anything specific, but just the Python interpreter, pretty much. All of them are there in this one zip file, essentially. Informally, we can just call it a zip file, but it's just a collection of files. When we run the container, it gets unzipped, so that from program's perspective, it's like it's running in a Linux environment, irrespective of whether it's running on a Windows machine or not. Okay, so if you want to do by command line, you can just type docker build and install Python pip so that I can install pip install Flask. Okay, so By the way, this technology is 11 years old. Docker was released in 2013. So yeah, it is somewhat old, like compared to LLMs, which are only a year and a half or 2 years old. But it's still relatively new in the software engineering landscape. But in those 10 years, it has any serious agency or any serious team which has not just data science teams but also software engineering teams also, they would have a huge this would be a component of their work, okay, day-to-day work. So we built that image, okay. So there's an explanation of what this is, which is what I just mentioned. So let's now start the image, okay. So how to start the image? So here's a command. It's just so this command that I wrote, even the previous command, so the Docker keyword is a program that's a client program. Okay, there's a Docker daemon running, which is getting those commands and is actually doing the job of creating that image for us. How did we create? We said Docker images. This is the client asking the server to say, hey, what are the images? Okay, so there is still a client server interaction. It's just that it's not HTTP interaction. Okay. So let's run this command, but it's not the right command. So let's actually, it looks like we have a, let me just check which port we are supposed to work. It says port 5001. So that was the one with which we created the image. So we have to kind of expose the appropriate port to things outside that box. Okay, so inside the box, the program is running at port 5001. Okay, this Docker container idea, you have to kind of make the operating system also see that port, okay, that port 5001. So there's going to be like a bridge or something that you have to connect those two ports. Okay, there's the operating system which has a port, which is the usual thing that we've been seeing so far, right? Like our Amazon virtual machine had the port 22 for SSH, port 8080 for HTTP or whatever. Similarly, we have to somehow connect our programs port, which is running inside the box, to operating system's port so that our browser can access, okay, or any other client beyond the container can access. Okay. So okay, our port is 5001. So let's try that. It's not the. Okay, I can just so minus D and so minus D means run in a daemon mode, as in not as a front running program, but as like a background program. Okay? Daemon just means like run it. We know that it's running. We can kill it later, but it's not gonna actively hijack my prompt I'll get back my prompt, for example. Okay. The P part means do the port mapping, which is what I was just explaining. So let's port map it to 3000, a local machine, which is my whichever machine that you want to host operating system. Sorry, the whatever machine that's running that container, and inside it's 5001, right? So that's the number in the that's the number here for some reason, and prediction. Okay, that's the name of the image that we want to run a container from. Okay, so that's what this is. This is for getting started. It's a different container, a different image, but and then let's press enter. Okay, so irrespective of what happens, you'll get a long string. That's generally going to be the ID of the container. ID as in like something unique which identifies the container. Okay, so let's see whether it actually run. Docker PS, PS just means list the processes. Okay, so it's just a list the containers running. Okay, on Docker desktop, you'll just see you'll have a UI where container is running. You'll see that directly. So you can see that for example, last actually not the last, but the first few characters are also shown here in the name. That's the name of the container, automatically assigned non-interpretable name. There's also some interpretable name here. It's called relaxed something. Okay, it's just automatically assigns this particular program. And which image did we generate from? Prediction. And what is the command? Python 3 Flask, our Flask file. And then it was created half a minute ago. And status, it's up. So sometimes you might see the status exited. Okay, this will be common when you're debugging your if you're trying to containerize your app and you did something incorrectly, your app will not be able to start. It will say exited or some other state. Okay, and then it's saying port or okay, I might have let's see if it works. If not, we'll flip the numbers. But actually, basically 3000 in our machine has to map to this 5001 inside on the container box. Okay. So let's try it, curl. Okay, it does work. So, I mean, I didn't want to flip the browser, but basically it will do the same. Okay, if you so what I did is curl is just a command line way to again make a get request to a location. So I said localhost at port 3000. Okay, and since I did not give any inputs, it said status is false, and this is something we've seen many times. X is equal to 5, right? Prediction is 12. Okay, now how is this prediction happening? This is not a I didn't run a Flask in some other tab, right? This is running in that containerized, I guess just call it container, in the container, okay, which is what we just ran. Okay, this container here. All right, it has a name, relax, whatever, but that's the container that we are making a request to. Okay, now this image actually that we just saw, this 500 MB thing, is essentially like a zip file. So I mean, it seems very preposterous to do this, but I could just say, okay, I can attach it to an email and send it to you guys and say, hey, here's the image for a machine learning model, and just download the image or whatever, get the attachment and run it. Okay, and the way you run it is exactly the same. You download it. Just you need to ensure that it's seeable by the local Docker daemon, but except for that, you can just say run it, and it'll be the exact same app. It'll run as long as the dependencies are there in the image. Okay? So it doesn't matter whether you're running on Windows 10, Windows 11, Windows 7, doesn't matter. Okay. So this was just a quick demo. I think there is more details in the getting started with a lot of other things. For their demo, this is what you see, some sort of a to-do list. So you can have like a you can write an entry and just add item or something like that. Okay, but we don't. It's all the same. Here it shows exactly what we did. To see list your containers, you can just do docker ps. Yeah. So actually we only did part 2, which is actually just first step. There are many other steps that we can do, which is what if you kind of want to edit your app. Okay. So for example, let's actually do at least this one. So let's say I want to do port 5002. Okay. This is not in the container, right? This is just I have a local file. I just change the file. Now I have to do the full steps again. I have to recreate the image, and then I have to build. I have to build that image, and then I have to rerun the container. Okay, those are 2 steps I need to do. But those steps actually, I was just saying earlier, you can do it very quickly. So for example, this is the command that we ran first time. Okay, I only changed the port, so nothing else changed, right? So if I press enter, you would see a much smaller log. Okay, that's because it directly skips the things that is already there. It's, as you can see here, it says cached and cached for step 2 and 3. The only thing that changed is this file. So we are executing the copy step, and then it's creating the image. Okay, so it's overriding the previous image. Okay, and so Docker images. You can see that now the same repository, the image latest, this particular new image has been assigned the word prediction and latest, and the previous image, their names are gone. Okay, their names are gone because they reused the word. If I had not reused the word, they would still have prediction latest, and this would have been called prediction new or something. But you can see it's the exact same bunch of files, except one file, just one number changed. Okay, so seems like a massive waste, like half a gig for each of them, but now you're containerized, so you can again restart. The previous one would continue to run, but now like I don't know, did I change? Yeah, 5002. Oh, 3000 is already being used. Let's give it to 5000. Okay, so okay, so you can see that now there are 2 apps running. One was the old one, and one was a new one. And new one you can instantiate the same way. I I guess not instantiate, but message the same way. So I think it was 5,000. It's the same result because we only changed the port, nothing else changed. But you can imagine, right? If you're going to update your code, much of it probably will not change, and you can keep rebuilding the images. And as long as it's available to other people, they can keep downloading it and update their things. Okay, so it's a really nice flow in a real situation where some teams will be focused on actual model building. Some people will be focused on packaging this, like with Docker, and some people will be focused on downloading them and putting them into machines and actually taking care of reliability and so on to the end users. So all this happens to all the apps that we saw earlier. 11 Labs app, ChatGPT, GitHub Copilot, all of them behind the scenes, there is this technology being used. I mean, we don't have to it's internal to them, we don't know, but I'm pretty sure they're using something like this. Okay. Any questions with this? We didn't achieve something miraculous compared to the first two lectures. It's still the same simple prediction model, but what we did is containerize it, put it in a container in a box, an image, and then spin up a container from that image. Okay. So I just want to mention last thing, which is that a container, when it's running like these two, right? These are nothing but I don't know, on Windows. I don't know how many of you have not used Windows or not used Windows. Not use Windows. Okay, on Mac also there's this activity monitor. On Windows there's the Windows Task Manager, right? You will see a bunch of processes, right? So all these, what are these processes? You can just think of them as programs. Okay, those are the programs that are asking the kernel for resources, right? Now these two containers that are running, you can think of them as also processes. Okay, they're also like two extra rows in your activity monitor or Windows Task Manager. They're also through Docker asking for resources from the host kernel, except that the program that's running doesn't know that it's running on Windows machine. It's just relying on, oh, I have Flask, I have everything else running. It's great. Okay. So, but indirectly, they're just processes, which is very different from virtual machine. Virtual machine is not a process. There is a software hypervisor or something, like a virtual box is an example of a hypervisor, but there's a software that kind of really virtualizing the hardware that's available in the laptop or desktop or on a server. Okay. So it's just processes. So you can, so these are running. So how to kill them? Docker stop the container, stop, and then you can give a name. Oh, Copilot explained this. I don't know what it'll explain, but system. Okay, stop doesn't work. We can just kill it. RM would be the command. For some reason, yeah. So you can see that I stopped that one. So there's only one container running remaining. And if you want to see all the ones, including the stop ones, you can do -A. And you can see that, yeah, it exited 13 minutes ago, 13 seconds ago. So we stopped it. Okay. You can delete them and so on. So RM means remove, stop is just stop, and so on. So you can do many of these commands. You can look at the manual for more information about that. Okay, if there are no questions, then let's see. Any questions? So first, I have some. Yeah, I have a couple of more examples of just the same thing, but they're not like essential in the sense this itself is, if it's new, then I don't want to show two more examples of the same thing. But those examples actually really show the value of Docker, because there's a very popular computer vision software which people use, okay, to find where the eyes, where the nose, and the face in an image. And that program, it's on GitHub, but it's very hard to install on your machine on Windows or Mac or whatever. But they also provide a Docker image, okay? So it's very easy to kind of download that image, run the program, and it's all containerized. So you can actually get in this case, landmarks or whatever. So I can show that maybe after the break, maybe separately, but that really shows you the value of having something like Docker. Okay? The software was created like 2-3 years ago. That underlying binaries and whatnot, I don't think they exist, and that's why people face issues. And so that's a great solution for that. Okay, let's then take a break for 10 minutes. And after the break, it's a free session. Try to see if you can redo some things. If you didn't follow, didn't ask a question, something clicked, you can ask me right after the break. Okay? Okay, there are only 5 students left. What I wanted to show was last time I think it's just a quick demo again of Docker, um, like a container, but this is like a local ChatGPT. Okay. Last time I think I showed you Olama as an example. I think they don't have an installation for Mac perhaps or Windows. One of those they don't have it. Yeah, I mean there are actually many others that you can install instead of them, instead of this one. But I think last time we saw on the command line how to do it, right? So we saw, let me just clear all this. So I had this binary or like a program called Olama, and we said if you just do /Olama serve, okay, that starts essentially like a Flask server. Okay, it's basically like Flask or Streamlit or Fast API. There are many different types, but it's running a server, and then I go here and then say Olama, list to know which models I have. I have some code helping model and then another model called fee. Okay, and you can see the naming convention also. Colon latest means okay, latest version of this model and so on. So these are the models I have. If I do fee, it'll just run the fee model. Okay, so it's like very similar to running a local version of ChatGPT. So this is, I think we tried this last time. What is it? We tried what is the capital of something. What is the actually it's not a, I think it's not a completion, it's not a chat model. So that's why it's just stopping at some random information. Okay, like you can say capital. Yeah, so that's what they're like yeah, actually it didn't work for some reason. Okay, that's not, that's a, I don't know what the deal is actually. It says there was a post request to some endpoint like that root that we talked about /hello. So there's a /API/generate for this guy, and it says there was a post request that was made, and it was able to respond. For some reason, we are not seeing the response on the other side. But what I wanted to show was a Dockerized version to have a UI very similar to ChatGPT. Okay, that's just an example of like, if you know Docker, you can do many things. Okay, this is the name of the repository. It's called Olama Web UI. Okay, so it's just a ChatGPT style web client for Olama, the thing that we are running. So okay, the fee is just I ran those 2 models only because they kind of are small enough that I could download them in time, and I ran it. But you can actually run pretty good models on, as long as you have a decent machine. Like it doesn't have to have a GPU. Okay, so you can run pretty much a clone of ChatGPT 3.5 at least. Okay, there's a model called Llama, which is by a company called Meta. So you can run Llama model, which is going to be pretty good compared to ChatGPT. So it's all local. Like for example, if you're worried about privacy issues and so on, you can just chat with it locally, right? But how do you get the UI, right? So there is a lot of files here, a lot of some software development that went on, and they're saying you can do a UI like this. Okay? So you can run, if you open your browser and go to some location, then you can have very similar to ChatGPT. There's going to be some information like previous conversation histories, some way to specify a model, and then you can give prompts here at the bottom. I don't think you can see it because of black background, but it's just a UI. And it has a lot of UI information. But if you scroll all the way down, how to install it, right? Steps to install, right? So you can install Docker. This is exactly what we did in the first half. We installed Docker, and it's saying for Windows users what you need to do, for Mac users, Linux users what you need to do. Then it's saying you should have the latest version of Olama. We have some Olama binary running already. And then check that it's running. So if you go here, it says, we have done it. That's why when we ran the serve command, it was running here. Okay, that's good. Then all we need to do is just run this command. Okay. So what is this going to do? It's going to download this. download this image from a location. Okay, it's some location, ghcr.io is just some website like google.com. Okay, ghcr.io is actually Google's container image registry. Just means like a GitHub for these images. So it's going to download this image, right? We created the image prediction image. Very similarly, it's going to download an equivalent image. Okay, and then the rest of it is just very interpretable commands. It's saying, okay, keep it always starting. We don't really care about that. Give a name for this container. It's, that's, pretty obvious. There's some extra, if you want to backup data, there's some extra information that you can add. And then since you're running Olama locally, because this UI has to talk to our local Olama installation, which is this, right? So we have this Olama running, sorry. It's running here, right? In our operating system, whereas the UI is running inside a container. So it has to reach out to this program to give that information so that it can collect back responses, right? So that's why there's an extra, don't worry about, I also don't know about this, but that's what this does. Okay, lets the UI connect to the program that's running in the host computer. Okay. And then the port forwarding stuff that we already saw for our app also. So we run this whole thing, which is what we're going to do. Let's go here. Oh, not this one. Let's go to another tab. And, I don't want to restart always. Let me just get rid of it. So what happened? I think there's some part which is missing. Okay. Oh, okay. This is to build our container. Okay. Actually, I should have copied this one. So for those who just came, I'm just trying to run another container, which is just a follow-up of what we did last time. Okay, which is last time we ran a model called Olama. Okay, let it run. So let's go back here. So this is that server. This is that client, which, okay, let me just type something. I don't think it's. Okay, this is like not working. Let's try the other model. Oh no, this is gonna download the whole thing. Okay, this is actually, I didn't specify the colon 6.7 billion parameter model. So it's just downloading a default model, which is a different one. Okay, in the meantime, let's see what's happening in the. Okay, def. I don't know. I mean, sorry, this is supposed to be. Anyway, you can see, right? Check if I think is this check. I think it dropped and it gave some other response, but nonetheless, this is just locally running. Okay? This is just a coding related model, very similar to Copilot that you can run locally, right? So let's go back here, right? So this, okay, port 3000 is being used and that's why it failed. So let's actually, sorry, I was running remember I just ran the web UI docker run command. It failed because port 3000 is being used. So we'll just kill that. Okay, I don't know, stop. taking some time. Okay, now let's run the same command that we. Okay. I'm just deleting the container which had the same name. Okay, so now if you go to localhost 3000, so we just ran it and it's running. Are we supposed to give a username password? Okay, let's see. Okay, does it say username password here? Okay, I don't know what the username password is. Let's see. Really? Wow, this is so weird. Okay. I don't know why they even have this, but okay, it's fine. Save it. You're using an older version. Okay, so this is where the version conflicts are, right? So the Docker container just has the web UI and doesn't have the Olama stuff. But you can see this is the UI that's running in that container. So whatever dependencies were there, we never installed all the crazy JavaScript related modules and all that is needed to run this. We just ran a Docker run command and we were able to run that container with the UI. Currently, it's saying it's not. We don't have. If it was connected properly, then you would see the. You would see the list of those two models. Those two or three models, you could choose it, and you could just say yes or no. It could also be because I didn't install the Olama binary at a path. It's not. It's not. Uh, uh, but although the path should not matter, so I don't know what the challenge is. But anyway, this is how you spin up a UI. We're not able to make it connect to Olama itself, the server, but that's something I can fix it later and let you know. Any questions about this? This is just an example of another Docker container, much more sophisticated, but we didn't have to install anything except since we had Docker locally, we could just download the image and run the container. Right? Any questions about this or? Okay, then let's pause.